Solving systems of nonlinear equations. My very first example I've chosen for you today is a parabola, that would be the red line, and a straight line, that would be the blue line. As we can tell by the graph, we have intersection point right here, and we have an intersection point right here. So that means that our solution to the system of nonlinear equations would be 2, 1, or x equal 2, y is 1, and 0, -1, or when x is 0, y is -1. Those are our two solutions to this system of nonlinear equations. Now, this is a graphical analysis. We also need to be able to do a algebraic analysis. One of the easiest ways to do this is by substitution. So I'm going to take this right here, which is equal to y, and I'm going to substitute it in for that particular y. So I'm going to do this algebra out to the side over here. X minus 1 equals x squared minus x minus 1. Now, when I use the algebra to solve this system, I had better get 2, 1, and 0, 1, -1 as my answers. So I'll throw everything over to the other side, and I'll get x squared. Then what I'm going to do is subtract x from both sides, so that'll be minus 2x. I'm going to add 1 to both sides, and then my 1's kind of drop away. I'll just solve this thing. I'll get x, factor out my x, and then I get x minus 2. So now I have two x answers. I have x equals 0 and x equal 2, and I need to find the corresponding y value to each of those. So I'll plug it into whichever equation I think is the coolest, and I happen to like this bottom equation right here. So that's the one I'm going to use. I'm going to say y equals an x minus 1, so 0 minus 1. That would be when x is 0, y is -1. So the first point I get algebraically is 0, -1. Yay, it's the same as that one over there, the graphical analysis. And then y equals, and that would be 2 minus 1. So y equal 1. So my next point that I get is 2, 1. Yay, it matches that one over there. So that would mean I got the right answer both times. It's so awesome. On my next example, I chose a system that has no answer, and I wanted you to see visually how it has no answer. There's no place where these two lines intersect, where they cross. So we need to see what that looks like algebraically. So what I'm going to do is I'm going to do the exact same thing I did last time. I'm going to take this, I'm going to substitute it in for y, exactly what I did last time. And then I'll get x squared minus x minus 1. And then I'll try to solve this system. So I'll move the x minus 3 over to the other side. And then I'll get this minus 2x. Add 3, so that'll be plus 2. The only way to solve this one would be, well, it's not the only way, but the easiest way probably is using the quadratic formula, because it's not going to factor nicely. So I'll use this. X equals minus b plus or minus square root b squared minus 4ac all over 2a. So I'll go ahead and start plugging these things in and looking at my coefficients here. Let's write down what a, b, and c are so that we make it easy on ourselves. A would be 1, coefficient in front of the x squared, b would be -2, and c would be 2. So this would be minus and minus 2 is 2, plus or minus the square root of -2 times -2 is 4, minus 4 times a times c, so that would be an 8, all over 2 times a, that would be a 2. At this point, I can see that I'm going to get imaginary roots, meaning that it doesn't cross. So this would be a -4. Notice how I've got a negative underneath the square root, meaning that I have no real roots. This thing does not cross. So no solution would be my answer. My next set of examples is a circle and a line. Now the green is my circle equation and the red would be my line equation. You can look here to see that they cross at, let's see, x is 3, y is 4, and they cross right here, and x would be 5 and y is 0. So there's where they cross graphically. So I need to solve this algebraically, because most of the time that's how you're going to be solving these. The graphical analysis is basically just so that you can get a picture in your head of why you have one answer, two answers, three answers, or etc. I'm going to solve this once again by substitution. I'm going to rewrite this equation. I'm going to move the 2x over to the other side so that I get y equals 10 minus 2x. Now this is what y equals, so I will take this and plug it in for my y right in there. So what I'm going to have is x squared plus 10 minus 2x quantity squared equals 25. I'm going to multiply that big old nonsense out. Remember, that's 10 minus 2x quantity squared, so I'm going to have to multiply it all the way out. Don't forget that it looks like, I'll just kind of write it light up to the side, it looks like it's 10 minus 2x times 10 minus 2x. So be sure and multiply that completely out. You will get 100 minus 40x, then plus 4x squared equals 25. I'm going to move everything all over to one side as I do when I solve a quadratic. So in combined like terms, I'll have 5x squared minus 40x, and then plus 75 equals 0. To make my factoring, because I'm going to try to factor this little booger, make it easier, I'm going to pull out the 5. Maybe that'll make it life easier for me. And it does. I see the 15. That's going to be a 3 and a 5. Lovely. Chunk, 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 chunk. So I'm going to get x minus 3, x minus 5. See how beautiful that is? That factors nicely. So when x is 3, I need to figure out the corresponding y value that goes with that. I can use any equation I like. I happen to like the linear equation right up there. It's that beautiful equation sitting right here. So I'm going to use this little guy to get my y values, my y answers. So y equals 10 minus 2 times 3. So y equals 10 minus 6. That would be a 4. When x is 3, y is 4. There's the first answer. Hey, corresponds up here. Beautiful job. Thank you. X equals 5. For my next one, I'm going to find the corresponding y. Do the exact same thing that I just did. Y equals 0. My corresponding x and y would be 5, 0. And I get the same thing that I got up there. Yay, very nice. This is my last set of examples, and let's look at this one. I've got what looks like, gosh, I don't know really what that is because it's kind of in the middle there. I see it's right around -1, I don't know, -1.6, -1.7, somewhere around in there. I've got this point here. X is 0. I got that one. It looks like y may be, I don't know, 2. I can't really tell what this one is. And I can't really tell what this one is either. So, but I can tell whenever I get my answers algebraically, I'll be able to tell if my answers are in the right neighborhood. So the graphical analysis will help me kind of go, oh yeah, that's about right. Because if I get an answer, say, of x equal to negative, I don't know, 5, I'd say, oh no, that's not right. So I should be able to look at it and do that. I'm going to use the exact same method that I did before. I'm going to solve this for y. Y equals 2 minus 3x. Then I will substitute this right here in for y. I'll find my x values, and then I'll find my y values. So I have x cubed minus 2 plus 2 minus 3x equals 0. All right, looks like my 2's drop out. So I've got x cubed minus 3x equals 0. Nice. I'll factor this. X squared minus 3 equals 0. Looks like for my first one, I'll get x equals 0 as an answer. I knew that. This guy right here. Oh, let's solve this a little bit. X squared minus 3 equals 0. X squared equals 3. X equals positive negative square root of 3. Okay, so I have two answers there that I'm going to have to piddle with. I'm going to have to do x equals positive square root of 3 and x equals negative square root of 3. It's getting a little messy there. So if x is 0, I'm just going to plug that in up in my linear equation because that's the prettiest one. I think I'll do that in a different color. Make it a little easier to look at. Let's see. We'll do blue. Y equals 2 minus 3 times 0. Y equals 2. My very first point is 0, 2. That looks reasonable. That was kind of my guess on that, but I wasn't for sure. The next one, y equals 2 minus 3 square root of 3. Okay, I'll need to see what that is as a decimal number, just so I can kind of see if it's right. And then y equals 2 plus 3 square root of 3. I went and got these decimal approximations for you just to see. Now, the square root of 3 is like 1.7 something. So let's just look at this very first x value that we got. If x is 1.7, then y would be about negative 3.2. That looks about right. And if x is negative 1.7, y is about 7.2. That looks about right. Okay, so these values are really, really close. So this means that my exact answer would be square root of 3 for x, and for y, 2 minus 3 onto the square root of 3. For my other point, that would be negative square root of 3, and 2 plus, 3 square root of 3. What a mess. All right. And that concludes our video.